Topic: Mechanics, acceleration and graphs of motion. Aims of lesson. The learners must 1. Understand the concept of acceleration. 2. Calculate acceleration. 3. Understand, draw and interpret graphs of motion. Introduction. From your previous lesson, you have learned that distance is the length of the path that an object moves along from one position to another. Displacement is a change in position. It is the magnitude and direction of the straight line drawn from the initial to the final position. Average speed, v, is the total distance traveled divided by the total time. Average velocity, v, is the displacement, change in position, divided by the total time taken. Concepts and skills. Part 1. In words. Average acceleration is the change of velocity divided by the time taken. Where v equals velocity, measured in ms1 delta v equals change of velocity, ms1 delta t equals time taken, s a equals acceleration, measured in meters per second squared, ms2. Acceleration is also a vector quantity, which means it has magnitude and direction. Worked example 1. A car traveling at 10 ms-1 due east accelerates and after 6 seconds is traveling at 22 ms-1 due east. Calculate the average acceleration of the car. Solution. List the information given. Take to the east as the positive direction. Deceleration is the term used to describe a moving object that is slowing down, or we can say an object's speed is decreasing. Worked example 2. A car is moving along a road at 15 ms-1. The driver applies the brakes when he sees a dog running across the road, for 5 s, and the car slows down to 5 ms-1. Calculate the car's acceleration during that time. Solution. List the information given. Take the direction of motion as the positive direction. Positive acceleration indicates an increase in velocity in the positive direction of motion. This means that the velocity and the acceleration are in the same direction and the object will speed up. Negative acceleration indicates a decrease in velocity in the positive direction of motion. This means that the velocity and the acceleration are in opposite directions and the object will slow down. Part 2. Uniform, constant, velocity, is described as motion with uniform, constant, velocity that has a constant speed in the same direction. Uniform acceleration is described as uniformly, constant, accelerated motion that increases its speed at a constant rate. Graphs of motion. 1. Graphs of motion for uniform velocity. Two. Graphs of motion for uniform acceleration. Tips on reading graphs. 1. Check which variable is on the vertical axis. 2. Check which direction is positive. 3. The velocity at any specific time can be calculated from gradient of the delta x delta t graph at that time. 4. The acceleration at any specific time can be calculated from gradient of the delta v delta t graph at that time. 5. The displacement up to a specific time can be calculated from the area under the delta v delta t graph up to that time. 6. The change in velocity up to a specific time can be calculated from the area under the a delta t graph up to that time. Worked example. A racing car starting from rest on the grid, travels straight along the track and reaches the 400 m mark after 8.6s. At the 400 m mark, the brakes are applied, and the car slowed down at 2 ms2 to come to rest. The two stages of the motion can be represented by delta x, delta t, delta v, delta t and a delta t graphs. Delta x, delta t. The displacement is always increasing, the car always moves forward. Gradient of delta x, delta t at point equals velocity at that point. The car starts from rest and ends at rest where gradient equals 0. The max gradient is at 8.6s. Delta v, delta t. The velocity is always positive, the car always moves forward. The gradient from 0 to 8.6s is positive, the car is accelerating forward. The gradient from 8.6 to 55.1s is negative, the car is decelerating while traveling forward. Graph of acceleration versus time. Activity/assessment. Activity. 1. The velocity of a car that is moving east increases steadily from 20 ms-1 to 35 ms-1 in 5s. Select east as the positive direction. Calculate the magnitude, size, of the car's average acceleration and give its direction. 2. The car in question 1 now slows down from 35 ms-1 east to 25 ms-1 east in 4s. Select east as the positive direction. Calculate the magnitude, size, of the car's acceleration and give its direction. 3. Compare the meaning of the terms constant velocity and constant acceleration. 4. The graph below shows a velocity versus time graph for the motion of a train on a straight track between two stations. A delta t. Constant acceleration of plus 10.82 ms2 from 0 to 8.6s. Constant acceleration of minus 2 ms2 from 8.6s to 55.1s. 4.1 For each of the intervals a, b and c, describe the train's motion in terms of its velocity and acceleration. 4.2 Use the graph to calculate the distance between the stations. The distance between the stations is the magnitude of the displacement because motion is in a straight line. Solution equals 1350 m. 4.3 Draw an acceleration versus time graph of the train's motion. Consolidation. Remember to study your definitions. Practice the quantities, their specific symbols as well as the units of measurement. Study the quantities, and how changing quantities can be represented in different graphs. Complete the activities in your textbook, based on this section of mechanics. Values. Be as accurate as possible. Observation skills. Evaluate. Analyze situations. Thanks for watching. Please like, share and subscribe.